Good morning, everyone. My name is Alex. I am the founder and CEO of Redpanda. Today, we're going to go through our launch event. This event is jam-packed with 8-minute bite-sized events. They are going to be short, crisp, educational, and to the point. So let's get started. We will be doing a bunch of live demos today, so let's pray to the demo gods that everything goes well today. If we don't, we do have video backup in case something goes wrong, but let's hope that everything goes well today. We will moderate a Q&A session with two of our customers. ISO will be joining us today from Poolside.ai. He is the CTO of Poolside.ai, building a foundational model. And then we also have Mark Oliver from Ikagi Digital working on banking. And so he will represent the enterprise customer. For those of us that are joining today, representing the enterprise. We will also have an AMA session where you will get to ask the engineers, the product managers, me, our customers, etc., all of the questions that you have. But I encourage you not to wait until the last minute to ask a question. Instead, ask the questions with the context as the speaker is going through their content so that you don't forget. Even if we get to answer, it'll give us the opportunity to tweak our narrative to be able to answer your question. And if we don't get a chance to add that as part of the narrative, we'll make sure that we answer in the live AMA. So join us and ask all of your questions there. And then towards the end, we will have a hands-on workshop. Sometimes it's hard as an engineer to understand the, what does this mean? What does this feature actually mean for me? And so, but when you have hands-on keyboard playing around with the feature, you'll get a sense of the value, like how it works. And so we'll close the session with that. Okay. So what are some of the Hollywood highlights, as I like to call them? I only have about 5 minutes left in this, so I want to try to just give you an overview of what is to come in the rest of this launch event in the next, I think, 72 minutes or so. So let me give you context. To me, the hero of the Redpanda story has always been you. The builder, the hacker, the doer, everyone that joined this call. And so we started the product building what we wish we had. They're parting away from what felt like distributed system whack-a-mole. For those of us that have been doing streaming for a long time, getting a Hello World up and running has always felt like, in case something goes wrong, you're like, well, I don't know if it's this or that or a system. When you have 5 or 6 different distributed systems interacting together to just get a Hello World up and running. So we started the product with a single binary that you can put on 1, 2, 3 computers, and then you were done. That was entirely the deployment model. As we got more experience with it, what we learned is that most clusters in the world were basically very expensive to maintain. And those were one of the 2 Achilles heel of streaming, right? It's always been complexity, which we tackled by making it super easy. And the second one was cost. And so we reduced the cost of Redpanda by offloading the local disk into tiered storage. We launched that 2 years ago. And that then allows developers to focus on real application metrics like latency and throughput. Last year, we released a product called BYOC, which divorces the control and data plane. So the data plane lives inside your network and the control plane is still cloud.redpanda.com, giving you a fully managed cloud where the data never leaves your network. And so you get to leverage your Amazon or Google or Azure pre-commits, pre-spends, and sort of instance that you have computed. But more importantly, the storage, the data that you produce, inclusive of the tiered storage, is in your domain. And that's different than privacy. What you get is this idea of sovereignty, which at a high level reduces to owning the hard drive lifecycle where your data actually lives. Of course, you get privacy too with that. And so that was sort of the centerpiece of placing you at the center of the Redpanda story. And today, I'd like to unveil our new transformation engine based on WebAssembly so that you can write code in your favorite programming language. We'll have a couple of SDKs. And so today, we'll give you a live demo of that. But hopefully, in the next 10 minutes, you'll be as wowed as I was when I first saw a 24 million parameter AI model being deployed, compiled in your local computer. and being shipped to the storage engine, transforming and enriching data as basically your Redpanda is accepting incoming messages on the stream, creating effectively zero latency or near zero latency for enriching or transforming or changing payloads, etc. So I don't want to spoil the demo that Tyler has lined up for us. But when I saw it, I was like, okay, this is the future of the bulk of the data stream, which is around like transforming messages and so on. So the idea of single shot transformations. For us in the CIO office, we haven't forgotten about you. Today, we are introducing two really fundamental features. One is data plane or OpenID Connect integration. So if you're managing hundreds of principals and applications, typically your IT organization will want to have a single pane of glass, often, let's say like Okta, right? So some ID provider. And you want to understand which principals actually have access to which clusters. And so OpenID Connect allows you to configure Redpanda to query in your OIDC format your provider to understand which clients, which principals have access to effectively authentication. You still have to pair the authorization with your regular ACL management, but it gives you a single pane of glass for onboarding and offboarding. We're also releasing the OCSF audit login format in a regular Redpanda topic, so you should be able to just consume it with a standard Kafka tooling or Redpanda tooling. And it is in the open cybersecurity format schema. So any modern system, CM system, whether it's a Splunk or Sumo Logic or AWS or IBM, anyone that understands this modern OCSF format should be able to just consume that. And you're going to be able to query and correlate events of, what was the timestamp and what API access by what principals and what was the effect of that. And then last, one of my favorite features today, because it works like magic, it is the idea of a whole cluster recovery with the snapshotting. So we all understand that disaster recovery is just a function of dollars, right? If you want to spend a significant amount of money to have synchronous replication around the globe, you could do that. But most people, that becomes too expensive, especially at the larger scale that a streaming tends to operate in. And so with whole cluster recovery, as we upload data to the tiered storage format, there's a checkpointing mechanism. And in case of total disaster, you would be able to start up an entire new cluster with access to all of the historical data with a single command line. And so if you configure that bucket to be multi-region, you can effectively survive a region. And then you can configure the metadata snapshotting. And so seeing it work for me in our cloud, our largest scale, felt like magic. And so I don't want to hold us back. There's an entire lineup of speakers. There's a ton of demos. I want to introduce you to my head of product, Matt, to dive deeper into all of these details. And so stick around for the AMA and our customer roundtable. With that, Matt, please take it away.
Thank you, Alex, and thank you to everyone for joining us today. So I think Alex did a really great job of kind of painting a picture of kind of the arc of the Redpanda story from its genesis to some of the major innovations over the last several years to kind of the through line and touchstones of our story, which are all about simplicity and really focusing on the developer and the developer experience first. He also talked about some of the Hollywood highlights of our latest release, which is called Redpanda 23.3, which is available now. So what I'd like to do is kind of step back and give you a quick overview or snapshot of the entire release 23.3, and then focus a little bit more on data transforms and why we're so excited about data transforms, which is going to help set us up for the first of two demos today. So let's go ahead and dive in. So with Redpanda 23.3, we're investing across the platform to up-level the experience for all the players, developers, the admins, the data platform owners, and the CIOs that Alex talked about, who are operating Redpanda in mission-critical environments. So Alex touched on a few key features in 23.3, data transforms, and this really marks a turning point for us at Redpanda, because it's no longer just about produce and consume, but about building extensible, composable, and complete end-to-end data pipelines from within Redpanda. And while doing that, keeping the simple things simple. He touched quickly on security and compliance features like OIDC authentication and audit logging. And these really up our game in the area of enterprise-grade security, especially with large organizations and in regulated environments. My colleague, Dennis Cody, is going to give you a great demo showing both of these features being used together in just a bit. And then he quickly touched on disaster recovery, about restoring snapshots of failed clusters easily with a single CLI command and operating a DR capability with much lower cost using a feature we call whole cluster restore. So let me fill that in with a couple of additional capabilities in 23.3. We're making the CIOs of the world happy by lowering their total cost of ownership in a couple of key ways with Redpanda 23.3. First, with faster upscaling and downscaling of clusters by leveraging tiered storage. So using the data in tiered storage, we can eliminate or minimize the east-west traffic across nodes in a cluster, and therefore the cross availability zone cost associated with scaling up and down. We can also complete upscaling and downscaling more quickly, more elasticity, lower cost. Also with significantly more efficient compaction than previous releases of Redpanda. So for compacted data, we can reduce the storage costs and the time to replay historical data, often by orders of magnitude compared with previous releases. We're also still focusing on the administrator, as I mentioned, in terms of enterprise-grade serviceability of the platform, operability of the platform, more self-service tooling to be able to recover from situations more quickly. We added a feature called recovery mode. So if you get into a sticky spot where there's been a misconfiguration, you figured something, you checked out a configuration file, you loaded it into Redpanda, and it's a mistake, you can quickly go and revert that. Or if you have an abusive application that's just created 20 million partitions and 20 million topics, you can go and deal with problematic partitions and topics using recovery mode and using some new APIs, quickly get back up and running. Or for slightly less sticky situations where you have partitions that are stuck, individual partitions or topics, maybe as a result of losing one or more brokers, with a single CLI command, you can quickly repair all the partitions on all those nodes and get back up and running quickly. All right, so let's focus now on data transforms and why this is so important. Data preparation is kind of a fact of life in streaming data environments because it's a hub and spoke architecture of various upstream and downstream systems, SaaS services, and sensors. They all speak different languages of data in a lot of cases, right? And so previously, even the simplest data preparation task would require standing up a new environment, scaling and managing a different cluster, for the developers perhaps learning a new framework or maybe even a new language, using things like Flink, Spark Streaming, or Kafka Streams to do even the most basic tasks. I actually have a customer who just has to correct timestamps. This is the one problem in their data. But sort of the marginal cost and effort and time to market for them to do that is enormous. With data transforms, what we're doing is bringing more of this work in broker into the message brokering environment, which bring you dramatic agility and efficiency gains. Agility, because the time to market for adding this value to the data, preparing the data, getting it in the format that consumers expect is much shorter, and efficiency because the data is not moving back and forth between these two environments over the network, maybe incurring cloud networking costs, certainly incurring a lot of additional compute costs, and being a very overall inefficient architecture to do simple data preparation tasks. Instead, we have this cost-efficient architecture where the data transformation is embedded inside Redpanda. There's no additional setup time, no new technologies to learn, and essentially no more data ping pong once you get into production. But how exactly do these data transforms work? Well, the way I like to think about this is we've sort of strapped an afterburner to all of the engines of Redpanda. We have these blazing fast streaming engines, which are all the cores of all your Redpanda brokers, running these pipelined operations on partitions and topics extremely fast with low latency and high throughput. And we've strapped this additional thing onto each of those engines, which is a very lightweight virtual machine based on WebAssembly. So every partition of every topic is running data through this transformation engine. So you have a raw data topic upstream, and you have a processed data topic downstream of this engine. And the engine is processing, transforming data per message. These are single message transforms. So you have one message coming in and 0 or more messages coming out. So you can filter data, you can break down more complex data structures with this, and so forth. These are essentially user-defined functions, if you think about it, as a platform. You can run arbitrary code and arbitrary computation safely because we have guardrails in place to make sure that transformations themselves are not consuming too many resources, and affecting other workloads that are running inside the platform. Today, you can author these transforms in Golang or in Rust, but we're investing in additional SDKs to make more developers comfortable with using data transforms if they're familiar with JavaScript or C++ or other languages in the future. So we're really focused on the developer experience and meeting developers where they are here. You have full access to your data schema when you're running transforms. So you can leverage the Redpanda schema registry, look up the schema, transform the data from the source to the target schema, decode, encode, use various data formats, and so forth. You can bring your own libraries, such as Go routines. And you can bring this all together to run common data preparation tasks, the simple data preparation tasks that we mentioned, like scrubbing bad data, redacting sensitive fields from downstream consumers, normalizing everything into one format, filtering out bad data to lower the egress volume, or just to protect consumers who are not capable of dealing with bad data, decoding, transcoding from JSON to Avro to protobuf to CSV to whatever it might be. Or you can do more complex tasks, like running an AI inference model with 24 million input parameters. And you're actually going to see that in the demo coming up in a minute. Data Transforms is in public beta in Redpanda 23.3 and will soon be available in Redpanda Cloud. All right, real quick, how do I actually use Data Transforms? Again, always focused on simplicity and the developer experience. We wanted to integrate this right into RPK, our command line experience. So in just a minute, you can initialize, build, and deploy a data transform. In this case, a simple regex replacement. You can use environment variables, bring in external configuration, and you're just writing a few lines of Golang in this example to complete this basic data transform. It's one function, no learning additional APIs, no specialized knowledge required of even using the Kafka API, just the language you're comfortable with. Now let's take a look at data transforms in action. For that, I'd like to invite up Tyler Rockwood, the technical lead of our data transforms team, to walk you through adding data transforms to an existing streaming data application, and also giving us a little hint and sneak preview about what the future of data transforms might look like. Tyler?
Awesome. Thanks, Matt. So as Matt mentioned, I want to walk through a case study and a little demo of an e-commerce application that today is using streaming for all of their order information. All of these orders and transactions that happen in their e-commerce application are currently going downstream to this fraud detection system. So in this transactions topic, they have information like who the customer was, what they ordered, their credit card information, other information around email address, delivery address, things like that. And what they want to do is spin up a new sort of downstream consumer to be able to do restocking so that they can make sure that as soon as things are being ordered from their e-commerce shop, they can make sure that the warehouse or wherever it be, that the inventory is fresh and up to date. And they can do this by in real time seeing what orders are being taken and then making the appropriate restocking orders. So to do this today, you might think, oh, they can just stream this data from these transactions topic. But the problem is with that is there's a lot of sensitive information in there. Like I said, there's things like addresses and emails and things like that that you don't want to expose to this downstream restocking application. So as Matt had alluded to, the normal state of the art for this is you'd spin up this whole separate distributed infrastructure and system to read this data in, do this really simple redaction of a few JSON fields and pipe it right back in to Redpanda. So the ease and simplicity of data transforms is that you can spin all of this up without any additional infrastructure directly in Broker. So now I'm going to walk through a live demo of this, showing you just how easy it is to deploy and build these transforms. So as a precursor here, these are sort of the different topics that is currently running for this e-commerce application. I have some orders that are coming through. And there's producers producing to this in real time. You can see there's some of this sensitive information here. And what I want to do is drop in and just show you how easy it is to create this redacted view of the data using data transformation. So I've just gone ahead and created this output topic that we will produce the redacted information on. And then I'll show you, I've already pre-written here a little transform in Go that unmarshals a JSON, redacts a few fields that we declared sensitive, and then marshals them, packages it back into JSON, and then writes it to the output topic that we just created. In addition, we have some small configuration that we write that says just the name of the transform, the input and output topics, and what language we're using. And then, as Matt had mentioned, our CLI experience has bundled a complete development experience in for data transforms. So you can initialize projects, which I've already done, and you've seen the code that I've written. And now you can also build these projects via a single command. We'll package the tool chains that you need, so you don't have to wrangle with different development environments. And now that that's built, you can see here we have our Wasm file here that's been deployed, and now that we're ready to deploy, and with a single command from RPK, we can deploy that to the broker. So now we can see that's been deployed into the broker, and if we go back to our console here, you can see our topic's been created, and there's new data flowing into this topic that's being transformed on the fly from that input topic. You can see we have our first and last name has been hashed, some other information's been redacted that we declare to be sensitive. And that's just how easy you can go from your input topic needing to sanitize some of this data in a new output topic. I'd also like to deploy or show you a second demo of just the power of WebAssembly and what you can do with these data transforms directly in Broker. So what I've done is taking a AI model from Hugging Face. It's a model called Mobile BERT. BERT's one of the original sort of big milestone papers and models that came out in 2008. And Mobile BERT's a slimmed down version of this that we can run in our broker. So it's 25.6 million parameters, I believe. And what we've done is we've used our Rust SDK for data transforms and compiled that model into a WebAssembly binary. And then I've deployed this onto a broker. And what this model has been fine-trained and fine-tuned to do is answer questions. So you can give it a small passage. In this example here, I've given a passage of our documentation for data transforms. And you can ask it questions, and what it will do is extract out from the original passage that we've given it the answer to those questions. So here's an example question asking, where do data transforms run? And you can see when we consume on the output topic, the model's already taken that and determined that the answer is directly inside the broker. I have another question here of what are examples of data transforms? And the answer is scrubbing, filtering, and transcoding. And then lastly, we'll ask it the question of some benefits for using data transforms within Redpanda. And it simplifies deployment and removes operational overhead of these different disjunct streaming systems. So that's my demo here for both how easy it is to deploy these and just the power of what you can do within WebAssembly. So I want to kick it back over to Alex for a demo, for a brief fireside chat with two of our customers from the banking and AI industries.
All right. Thank you so much, Tyler. That was amazing. When I first saw this a few weeks ago, I was just like, I hope I don't get to leak this. I was super jazzed. I want to welcome ISO. Thank you so much for joining us from Poolside.ai. And Mark, I think, Mark, if you want to unmute and bring your camera on, joining us from Ikagi Digital, building a commercial banking application. So given that this is just a fast and punchy, let's just get right into it, if you guys don't mind. ISO, tell us, how do you think about building a foundational model with the streaming first versus the alternatives?
Yeah, so streaming first is probably not obvious for most people who are working on foundational models. The reality, the standard is you build your very big Spark data pipelines that at the top of the funnel essentially process the equivalent of the entire internet. For anyone interested, the internet in text is less than 160 terabytes. And you build your traditional Spark pipeline. But on our end, what we see is in the data transformation steps that we do, we work from a very large data set to, at the very end of the funnel, a much smaller data set, usually about 10% of the original one. And every single step that we actually do in our data processing requires often different types of compute. We can't, unfortunately, run mobile BERT. We actually need to run incredibly large models, often over GPU clusters that span 1,000 GPUs or more to process data. We might need to run rule-based filtering, including regexes and rules like traditional ones that might span 400 high CPU core machines on Amazon. And so early on for us, we made this decision that for every single step of our process, if we would go from topic to topic, we would get a bunch of advantages. First of all, the main advantage we would get is that the person on the team who would be working on one of those transformations could both pick the hardware that they wanted, but also would be able to actually write the code that was optimal for it. So our deduplication step is a hardcore natively written C++ with a ton of optimizations in CUDA code, but our more data-oriented engineer who is working on rules needs to use the Python ecosystem. And that's just something that's really hard to do with traditional Spark pipelines. Now, on top of that, there's one other thing that we are now working towards, and we're very close to it, is the data sets that we train these large models on, we count in tokens. So 5 trillion tokens, every token's 4 characters. So there's this extremely large amounts of data, and it takes time to prepare high quality data. So while we kick off a training run, we can have already, delivered in a topic 1 trillion tokens and actually deliver the remaining 4 trillion tokens over the course of the rest of the training run. And our training system is now soon at the point where it's just going to be reading from topics instead of deploying these massive, data set files that we then need to distribute over, 200 nodes. And so for us, it's been a major both ergonomics for developers. And frankly, we've by adding a little bit of orchestration, you can get a lot of advantages. And for us, tons of experimentation, right? Our experimentation might go from one topic to another, and we might want to take only 5%. And all of a sudden we can do that now. And if we do this in Spark pipelines, well, it's a nightmare. So that's a little bit about how we use it. I think we're the first, as far as I know, to do so in AI on language and code in streaming. And so pretty excited to share more about it.
Yeah, gosh, thank you so much. This is such a new field for me, and it's a privilege to get to learn from you. I guess I love this idea of being able to start to get value out of this idea of incrementality, right? Like, as you have your data, I was like, okay, but let's start to monetize this particular stream while you're training it, just because it's so expensive. And then the ergonomics of just being able to, lack of a better word, like onboard a new engineer super quickly. And it's like, hey, just sample this data or use perhaps a read replica cluster or something like that. And then you don't have to worry about the complexities of taking down a production cluster or something like that. That seems to me like a very different approach from how a lot of other companies have built. How did you come up to this idea? Like what gave you confidence that this was going to work?
I wish I had a really nice answer for you on this. The very honest answer is a very strong dislike of Apache Spark.
Yeah.
And so so streaming seemed natural here. Now we started and scaled this up a bit. Admittedly, we first tried this on Confluent and we just couldn't get the throughput and skill that we wanted. So and I kind of knew we should have gone to Redpanda first. So we made that shift very early on, what we've been really excited about. And then it just started, the ergonomics started showing. Like one thing I didn't mention, for a lot of these topics, we are also streaming the data into ClickHouse. So all of a sudden, while we're running an experiment or we are processing data, I can go run aggregate queries over billions of documents in ClickHouse in seconds, with something that I'm completely familiar with, not some, obscure Kafka-like, SQL language, but instead I can just actually use, a high-performance columnar database. And this has kind of just been like, we've built our confidence. We started with smaller data sets, and now it runs all of our data pipelines, and it's actually permeating in other parts of our organization and system. So frankly, we've been quite happy. I think the only thing that we had to teach people was, what partitioning is. Because it's really that easy. A new engineer comes on, it's like, use this library in and out, and you just have to explain partitioning. And frankly, once people understand that, everything is very obvious.
Awesome. Thank you so much for sharing. And for those of us new in the audience to streaming, the idea is the topics are unordered collections, and partitions inside each topic are totally ordered collections. And so a topic is a collection, is an unordered collection of totally ordered collections, if that makes sense. Let me switch gears here for a second. And Mark is joining us, I think, representing our enterprise customers, people that have to deal with gnarly systems and integrations, etc. So Mark, perhaps tell us a little bit, what is it like to build in a data infrastructure for a bank, for a new bank, and how does streaming fit into that?
Yep, so yeah, we build data infrastructure for brand new banks, greenfield sites, which does make it entertaining when you have no data. So normally we kind of go into a bank and you've got lots of data and you're trying to retrofit. Going with a greenfield site is actually just as difficult. You've got to try and get the customers to partners to work out what it is they expect them to come. But that does give us some unique opportunities to improve data governance and data quality by enforcing kind of data contracts up front. So that's where we're looking at going. Bringing in Redpanda is really helping with that. Great schema registry in there. The other kind of slightly unusual thing we're doing is a lot of banks traditionally would have built everything in-house. They wouldn't have really used kind of many partners, or if they did, they'd be kind of purchasing off-the-shelf products and embedding them directly in their business. We're very much more the SaaS model. Everything is integrated, but we're using Kafka as our integration point. So traditionally, most industries would use Kafka only inside the company. And this is one of our reasons of not choosing kind of on the main competitors. Actually, we needed to be able to reach out to partners in different networks, but still keep them within that kind of BYOC cloud infrastructure, so they're all on net to us.
Awesome. And what are some of the gnarliest data challenges? I mean, honestly, I think of banking, and like in my mind, I'm thinking like 30 years worth of compliance that I need to go and figure out. If I'm an engineer, and so like, just curious as to like, what are some of these gnarly data challenges, and like, how did you think of streaming, right? Because the easier thing, superficially at least, would be to like, hey, let me just do this batch file upload or something like that. And so I'm curious as to like, what made you think of streaming first? I mean, something had to come to that realization. I think you mentioned, well, maybe integration with partners, that was a big one. Maybe it was like BYOC, or maybe it was Wasm. Like, I'm curious how you were thinking about it.
Yeah, integration with partners is definitely a key there, but really it's shift left analytics. We need to keep that data moving. Every time we get that data at rest, the party stops. Customers these days don't want to wait for the music to stop. They want to see their data in real time. The engineers don't like it, but the end users, the CEOs, the execs of the bank and stuff, they love it because they can see their dashboards in real time, see what's happening in the bank.
Yeah, awesome. Now we're coming up time here. If for those of us in the audience, if you have additional questions for ISO or Mark, they're going to be joining us in our AMA. So think of all these spicy questions that you want to ask our two experts, and we'll be happy to answer that. Let me close this session by just kind of open-ended. We'll start with ISO here. What are you looking forward from Redpanda and like the integration? Is it tighter integration with ClickHouse? Is it, Iceberg? Is it Wasm? Like what are you looking forward to the most? And then we'll after that, we'll kick it over to Mark.
It's a really good question. What I'm really excited about is that essentially Redpanda has become the source of truth of our data, which is a very different mindset than I've previously had, right? The source of truth of our data was S3 files or our database. But now we actually see Redpanda as this central source of truth. And so where I'm really excited about is seeing actually for us Redpanda and things that are coming out in the future really becoming that indexing layer, right? I'm excited about anything that we use on top, if that's ClickHouse or other products or services, that Redpanda is actually what matters. And to me, that was a big mindset shift, because before that was definitely not how I thought about the world.
Yeah, I think that there's this idea that streaming has only been used for this like ephemeral use cases, but as you start to integrate with tiered storage and like, it's relatively cost effective to put these things on S3 or GCS or Azure Blob Store. Like, why not? There's a really great post by the systems builders at Amazon where they say like, the log is the source of truth and everything else is just the cache. So it's almost like you're thinking about it in a similar fashion. We're like, okay, this is my indexing layer and everything on top. It's just like, it's a cache, it's a materialized view, it's a query table. It's just like the way I access the data, I'm going to shape it a little different for the mode of access. But largely, this is like perhaps the fundamental shift that you had.
Yeah, no, absolutely. And there's one thing I cannot stress enough in terms of this is this notion of that you are running in your, like, bring your own cloud, right? We can run all of this like massively cost efficient in our US East 1 region on AWS. So everything else that we're deploying is living in that same region, and then we avoid massive amount of crazy AWS networking bills.
Yeah, which is like they would be happy to let you transfer a bunch of data and just start, and you're like, I just queried that data. Gosh, I wish I had so much more time to get deeper into that. Maybe we'll get into cost efficiencies in the AMA, but Mark, I'm curious as to what you're looking forward to the most in like Redpanda.
Yep, I have to agree with Etso on what he just said there, but primarily we're looking forward to the Iceberg syncs and also Wasm to be able to enforce that data contract and stop those data quality issues right up the front, but also get the data into a format that I can use in real time for the analytics side of things. Which is, yeah, so having Iceberg thrown out of Redpanda will be absolutely amazing.
Awesome. Well, with that, thank you so much, both of you, for joining today. Super excited to have you. Again, for those of us in the audience, please ask your questions right now, and then we'll answer it in the AMA. With that, let me transfer this to Dennis Cody, who is going to join us and talk about OCSF and a bunch of other goodies. Dennis, take it away.
Thanks, Alex. So I'm actually pretty thrilled to share some great updates that Alex has already hinted to, revolving around our product security that we've been working on for the past few months. I'm actually really excited because these are things that you folks have been asking for a really long time for. So let's dive in. The first big update is Redpanda now supports OIDC single sign-on authentication. So think about the numerous apps you use every day, your emails, BI tools, your chat applications, etc. Managing more accounts and more passwords is a compliance nightmare. We don't want to just improve your user experience with authentication. We're really also focused on improving your administrative experience as well. The more we can do and the less you have to do, the happier you're going to be. So to do our part, we complement our existing suite of authentication methods now with support for OpenID Connect, or OIDC. So what does this buy? You can now seamlessly integrate Redpanda with your existing identity provider, whether it's Okta, Azure AD, or even on-premise Active Directory. So this means you no longer have to manually create SASL accounts for people, because you might have hundreds or thousands of employees. And instead, folks can access your Redpanda instance using existing provider credentials for both your users and your services. So, ultimately, this is going to lead to quicker onboarding and offboarding of users, use cases, and spending a whole lot less time, just tracking accounts, for your compliance needs. So now let's shift to another very requested feature, audit logging. So we wanted to build something that's pretty easy to use, that's going to help you stay in compliance, right out of the box. So what we built is a solution where when you enable auditing with Redpanda, events are stored in a read-only topic that protect your audit history from, even delete happy at super admins, or people like me that accidentally delete things because I'm not careful. But what's really cool is the level of detail you're going to get. Because Redpanda logs everything from API requests and client connections, administrative events, changes to cluster and topic configs, and even when users read and write from topics. So the whole shebang. And you get all of this with negligible impact to your performance. So when it's great to have it in Redpanda, but a lot of times you need to take all of these events and put them in some sort of centralized infosec tool. So because they're stored in a topic, you can just use your favorite pre-built connector or consumer and just ingest them directly into your tool, like you probably do with Kafka today. The one big thing I want to point out that Alex also hinted to is, so rather than going with a proprietary choice of audit format, as so many tools do today, there's a new open standard out there. It's called OCSF, Open Cybersecurity Schema. So we wanted to use something open. And this is a standard which is being rapidly developed and adopted by the security industry. And we feel that using an open standard schema will ultimately, reduce the amount of effort that your InfoSec teams are going to need to do and to pull data from Redpanda. So here's a kind of a quick overview of a demo I'm going to present. In a couple minutes, I'm going to try to create a new consumer application using OIDC client credentials, and we're going to watch it, consume some data, and we're going to take a look at some of the audit events going on in Splunk. So with that, let's get to it. All right, so what I have set up is just a pretty vanilla cluster with Sassel turned on. So what we're going to do in a few minutes, step one, we are going to go ahead and enable OIDC and auditing. So first, we're going to tell Redpanda, hey, this is my well-known discovery URL. So this is what I want you to use to authenticate my users. We are going to tell Redpanda now for Kafka and our HTTP APIs, use OIDC. And now we're going to enable auditing. Cool. Good to go. So what I'm going to do now, because I don't yet have a service account, I'm going to go to Okta, and we're going to create my service account for my new consumer. So for that, we'll go to Applications, create App Integration. We're going to choose our good friend OIDC. We are going to name this Demo Consumer, because I am very creative. We'll choose Client Credentials. And great. So the two pieces of information we really need are going to be the client ID and one of these client secrets. So I already have a pre-made Jazz file. So I'm just going to copy these values over for the secret and for the ID. So now going to my consumer. So as we can see, we're authenticated, but we're not yet authorized, because as Alex hinted early on, authorization is still built and centralized within Redpanda. So however you want to do any authentication, it's all done the same way with our ACLs. So I'm going to go ahead, create an ACL. Our principal in this case is going to be the client ID. It's a demo. Don't do this in production, obviously. I'll give it all permissions. Coming back here, let's start our consumer. So as you can see, I'm reading from a cryptocurrency exchange, getting real-time updates of Bitcoin prices. But now I want to take a look and see our auditing. So I'll go to topics. It's actually an internal topic, so we'll click this Show Internal Topics. Here's my audit log. So we get a lot of really rich data here. We have things like who's doing the action. In this case, it's an admin account I have for the console. You know, where are they talking to? What is the HTTP interface that they're using? You know, it kind of goes on. It's pretty great to see all this data here, but frankly, I think that I would prefer to try to use it in something more like Splunk. So I went ahead and created a Splunk connector in order to see it in Splunk. So just going to paste in the client ID here. And as we can see, you know, we have the who, what, where, when, and why of our events. You know, it's very rich. We have everything here. We can see what was authorized or denied, what they were trying to do, what policy either allowed or denied them. You know, and we have many more fields to choose from. So there's something there for everybody. And in an open format, that should be much easier for folks to ingest. I know I've thrown a lot at you in 5 minutes, but for more information, you know, feel free to ask questions in our AMA or check out our docs. With that, I'm really happy to introduce Redpanda CMO, Mike Boyarsky, to lead our AMA session. Take it away, Mike.
Fantastic. Thanks, Dennis. Awesome demo. It's not easy making auditing and authentication look really cool, so appreciate that. All right, so what did we see today? Just as a quick recap, we saw data transformations, very excited. Authentication integration with OIDC. We also introduced some new auditing capabilities. And then lastly, cluster snapshotting for better DR. So with this, we're going to move on into our AMA. We have a quick question for you all before we get started. So please, if you could ask or answer this question, what's your level of experience with Redpanda? We'll just give this a minute. Very cool. All right. Let's get into it. All right, let's bring our presenters back. So if everybody can turn their cameras back on. Cool. We got a lot of questions. So we're going to try to get through as many of these as we can. If we don't have time, we'll respond to you in email after the session. So keep the questions coming. So let's get going. The first one that came through, it's pretty consistent, pretty popular. Alex, I'm going to hand this off to you. The new data transform support, how would you compare this to something like Apache Flink?
Yeah, great question. Flink and other frameworks like it are very complete. You know, they are designed for large, stateful, in-memory aggregations. They tend to require a set of engineers to maintain them and deployment to production, unless you buy a SaaS. But generally, sort of the getting started with Flink is not as straightforward. And so the idea with WebAssembly is like, let me reduce the complexity as small as possible to a single function. If you could write a function, then you should be able to write a WebAssembly transformation. And the scope here is basically for the 60 or 70% of the data pipelines. And look, I've chatted with probably 1,000 companies now, maybe a little more, and 60% of the conversations for those companies are about transforming, you know, JSON to protobuf or Avro to this or XML to whatever, like Air Force format. There's like this abundance of formats. And so most things are about cleansing, are about like filtering, enriching, GeoIP, and this idea of single message transform. So today, WebAssemblies are complementary to large stateful aggregation frameworks like Flink or Spark or whatever, right? Like all of those things. And so they're really designed for these one-shot transformations that encompass, I think, in our opinion, the bulk of the data engineering pipelines. I'll leave it at that, just as a function of time. And hopefully that answers any questions. So for those in the audience, please feel free to have follow-up questions on that.
Perfect. Thank you. We're going to keep going into the data transform support. Tyler, I think this question is great for you. How do you ensure that rogue Wasm functions don't cause broker issues and other downstream effects?
Yeah, that's a great question. So one thing that I think that's really awesome about WebAssembly and the virtual machines that run WebAssembly is that there's a ton of control that we have within the broker to suspend these transforms or limit the memory. Every resource consumption that VM can use, we are able to put bounds on them. So for example, if you had a bug where you had an infinite loop in your transform, we will just run that. We will time slice the VM time that it runs within the broker with the actual client facing traffic. So you don't want, you know, a produce request comes in, you don't want that VM to sort of hog CPU and not let that happen. So we will suspend we'll suspend that VM and let that request come through. Similar in terms of memory, we have a strict bounds that we keep on how much memory you can use within these. So you can, you know, ahead of time sort of budget for how much you want to, how much of your resources when you're creating your clusters, you want to carve out for WebAssembly. And the VM doesn't allow you to grow the guest memory more than that. So those are just, I think, two fundamental resources that we allow and support doing some sort of limiting on and prevention from bad actors, essentially.
Yeah, perfect. Well, maybe just to keep you on the mic just for a minute, and then we'll ask another question. But there's a lot of questions around languages that are supported for authoring transforms. So if you could just maybe highlight current thinking and then maybe some future state support that you have in mind, that'd be awesome.
Yeah. So for transforms, I mean, technically anything that compiles to WebAssembly in the WASI format, in the WASI standard, we can run. We do have a specific ABI contract between the broker and your code that runs, a sort of contract of how we pass data back and forth. And we have written SDKs that sort of ease that burden of needing to understand what that exact format is. So currently we have SDK support in Golang and Rust, and we'd like to expand that as time goes on, and giving us input into those decisions help us make the right prioritize languages appropriately based on demand. So let us know what your favorite languages are and what you'd like to use for transforms. But yeah, today we support Golang and Rust, but really the sky's the limit. Almost anything that compiles to WebAssembly, which is a ton of languages, we can run in Broker.
Perfect. Great. Thanks for that. We'll probably get back to you. There's a lot more questions coming, but we're going to move on to a slightly different topic, which is around the BYOC model. And maybe with ISO or Mark here, you're welcome to chime in, but there's some content and some maybe you can call it FUD from the Confluent blog write-ups around BYOC as a model and whether it's a good bet. And so the question here is, why should I bet on BYOC as a construct for my data streaming?
You want to go ahead, Mark? I'm also happy to take a part of it since we evaluated both, but I'm sure you did as well.
No, to fair, we only looked at BYOC, which is why we came this direction. Yeah, for banking, it's a very regulated industry. Getting that level of trust, going completely SaaS and having the data in your account is very hard to get past the auditors and proven bits like that. Having it inside our account, we can see it. We've got all the logs. It makes it a hell of a lot easier to get past auditors, show them, okay, this is exactly what's happening, especially with your new audit features as well. It's going to make it really easy. And we get the benefit of cost savings. We can scale up and scale down much easier.
And this may be a good leverage point for me. So it's exactly what Mark is talking about here in terms of like the cost difference. For us, it was performance and cost. And Redpanda won out by a long shot on both. But I don't think people really realize how large the cost difference is, particularly at least when you're dealing with very, very large amounts of data or very high throughput speeds. And personally, I would say it's that combination of incredible throughput and stability and high amounts of data that I would say Redpanda is particularly strong at. For us, it looked at almost a magnitude difference over what we were expecting to spend. On top of that, frankly, it runs really smooth. Like, I do not think about Redpanda as running on our cloud, because we've been running this for some time now, and we never have to think about the infrastructure, right? The infrastructure just works, and having visibility as well into where we're spending our money, right? What's compute, what's network, I think is massively valuable. And then to my earlier point, if all of our data lives in one region, meaning we can move it around freely on AWS in our case, that's not the same when you go with a managed product where you don't have any insight into this at all.
Well, you remember our chats, ISO, and anyways, I was on paternity leave because I had twins, and then I one of our accounts are like, hey, like Polza is doing multi-gigabyte per second, and we literally didn't even notice. Like it was just sort of like the system finally worked, and it's scaled, and it was a non-event for anyone, not for us, not for you. And that's really sort of the kind of experience that we hope to deliver. I think that there's like this idea that, hey, this doesn't work, or people really start digging into some details that tend to misrepresent actually access or ownership of that. And so there are two, I think, important things. One is the cost between access of accounts, I think is an important one for you, but also the latency, right? Like you could deploy your code right next to the storage engine. So you could do, we were talking about earlier, as you were exposing how you were thinking about building a foundational one. You're like, look, I have an engineer, CPU, like regular data thing. I have another thing, it's like custom, handcrafted CUDA code. And like the ability to get low latency to those products, but actually not worry about both is what we hope to deliver. So it was really fun seeing you scale to multi-gigabyte per second workloads, and so that was the hope with BYOC originally.
And that's scaling down, right? For us, there's periods where we process massive amounts of data, and then there's periods where we're running smaller experiments. And actually, that flexibility of scale that I can have with Redpanda is surprisingly hard. It should be easier on a managed cloud, but actually it's not at all. It actually ends up being significantly easier doing this with Redpanda. And I don't want to sound like I'm a fanboy, because I'm hearing myself, but frankly, having run both, and we couldn't do what we are doing with Confluent, and we've been very lucky to be able to do it with Redpanda.
We're lucky to have you. Mike, over to you.
Yeah.
One more reason we did choose Redpanda was actually was networking. As I said before, we have lots of partners. We couldn't integrate with those partners on Confluent. If we wanted to do that, we had to have a public clusters and let them connect to public clusters, which is just bad for traffic and not allowed. So the ability to privately connect to our partners using BOIOC was the real reason and the main reason we chose Redpanda.
You know, networking is such like an underrated cloud feature. It's just sort of like this plumbing thing. It's not sexy. It's not part of this launch event, to be honest, but like it is a blocker for so many people going with BYOC. I think there's like a couple of things. One was basically access. Can you have effectively an allow list of totality of commands that the agent can act on your data plane behalf? That's one. And then two, is the networking sophisticated enough to actually enable commercial banking? That's sort of the bar that we were trying to meet there.
Super great. Thanks for the back and forth. And again, the questions that are coming in, we're kind of we're getting close to our limit. We'll have one more question, but continue to ask because honestly, we will respond. So if this is your opportunity to get experts to answer the questions that you have right now. The last question is back to maybe the product team. I don't know, Tyler, Matt, either of you. So there's a question around extending the Wasm framework so that it can focus, so it's not focused on single message at time processing, but goes towards more, I guess, of the case SQL variety in terms of support. So just any thoughts, comments around how we're thinking about the future state of the framework?
Yeah, I definitely say we're going to take things in that direction, but there are sort of limits and trade-offs as we sort of try to protect the low latency guarantees and the high throughput for other workloads, which may or may not be using data transforms. I think Tyler can probably expand on this a little bit.
Yeah, I would say as you start to do more sorts of complex computations, joins of different pipelines, there becomes a lot more resource requirements to do some of those things. And that may not all be feasible within the broker. We're still in the phases of sort of exploring some of those things, but yeah, I would say stay tuned.
Perfect. Great. Thank you all for being part of this session. And also for folks in the audience, if you can give us feedback, if you like this format today, let us know. And if you want some adjustments, do that too, because we want these types of launch events to be the best possible experience. So with that, we're going to move on into our next portion of today's session, which is hands-on lab. And so before doing that, for those that have to drop, it's okay. We're going to send you a recording of today's session so you can replay and watch as you like. There's also additional resources for you all. So if you want to learn more and how to use Redpanda, we have our university content, which is amazing, self-guided, online, gives you the concepts, it gives you how to use and set up Redpanda and how to build on the platform. So lots of great resources for you. In addition to that, we've got our world-class documentation. Check out our Slack community if you want to ask questions there. We're certainly very active there. We have lots of expert customers as well that participate. And if you want to get into the code, it's available today. It's in our GitHub repository. Take a look. That's where our community edition exists. But with that, I do want to give Tyler an opportunity to get you all trained on how to use our data transforms support. So I wish you all good luck with that. And so Tyler, take it away.
Awesome. Thanks, Mike. Share my screen. All right, so we're going to transition into a workshop. So here we're going to be sharing a link to Instruct, which will have our workshop here in a moment. But I just want to make a note that this session that we're going to share here in the during this event is going to be accessible for 24 hours. And you can do it anytime during that time. If you want to run through it in your own time, maybe later, if you have to drop now, whatever it may be, we will be sending out new on-demand links after this event, which won't expire. So you can take and do these at your leisure. If you need any assistance during this time, just raise your hand in Zoom and we'll be able to send you a link to get one-on-one help or ask your questions in the Q&A as well, and we can answer them there directly. So what I want to walk through is sort of what this workshop is going to be on and what you're going to be building. So what we have here is a food delivery application where you know, you place your order and then you get a delivery status of your food's going to be ready in X amount of minutes, and here's you know, here's how long it is, and you can track that, etc. So what we have is here is a machine learning application to do these sorts of predictions on when your food's going to be delivered. So what we have built here is a little simulator to produce these sorts of delivery events of food's ready, food's been ordered, food's been delivered, etc. And that goes into a Redpanda cluster onto each node in a topic. And what we're going to do is, what we want to do is forward that information into a machine learning model so that we can, in real time, continuously be training this model so we can swap it out, and you're always getting the latest inference, the latest predictions on based on your real-time data of when your food should be delivered. So in order to do that, we need to massage the data format to insert it into the rest of our model pipeline. So what we're going to do is build a transform written in Go, compile it to WebAssembly using RPK, our command line tool, and we're going to deploy it onto the broker. The broker will then, with each of these engines, as Matt had described at the very beginning, process these to get new events. So every time one of these delivery events comes into the cluster, it'll be produced onto a topic. The data transforms engine will take that data, run our code that we've built and written, and then produce it to a new topic that we can then forward into our machine learning model, which then we can train that model, get the latest up-to-date predictions, and then swap it out in real time so that you always have the latest and freshest predictions that are coming through. And then that can be serviced in our web app for users to sort of see when the latest stuff is going to be available. All right, so here's the link. We're also going to drop this in the chat, and I'll walk us through as people are getting set up, how to get through this and go through the workshop. We're going to have about 15 minutes to sort of walk through this. So I'm going to transition over. I believe the link's already in the chat. So I'm going to transition over. I already have logged in, and this is sort of the view. Once you've clicked that link, you're going to have to, you know, enter in your email address and your name, and then you'll get dropped into this environment, which you have a terminal up here. You can switch to an editor, which we'll use to author our transform, a Jupyter notebook, and then the actual Redpanda console itself. And then you can, if you look over here on the right, there's this panel here that you can click play to sort of run play by play as you read through sort of the scenario and the workshop. You can sort of in your own time run this code snippet and step through the tutorial, or excuse me, the workshop. One note I am going to have here, we have another command that you need to run before you, in this phase, as you're typing out commands, there's an extra export command to add Golang to your path that we did not get into the lab. So just remember that there's an extra step that is in the lab. If you have any problems, like I said, just feel free to raise your hand or ask in the chat, and we're happy to assist. So yeah, I'll let you go ahead and walk through this at your own leisure. We'll put up a timer here for about 15 minutes or so. Yeah. Hello. Thanks. We have about a minute left. We'll start wrapping up this portion of our event. But I just wanted to make a note of this. Like I said, that link that we have in the post, if you're working through the workshop right now, that's available for 24 hours. You can run through it at your leisure as time. If you have questions, you can feel free to ask here or jump into our community Slack. We'll be around as well. And then again, if you weren't able to do it during this time, we'll be sending out links afterwards that you can do this later at your leisure, or and also links to the whole recording of this event, so you can view it at your time. Before we sort of like start to wrap up here, I just want a quick question for folks, a poll of just how technical was this session? Was it not technical enough for you? Was it just right? Was it too technical? Would you please just, let us know. We'd love to see that. Cool. Got some answers coming in. We'll give it a little bit more time for this poll to work through. Awesome. Great. Thanks. So I just wanted to again highlight sort of what Mike had mentioned earlier is we have some great resources available for you if you want to learn more about Redpanda. We have our university, which you can go on yourself, pace yourself for online learning, just how streaming works, learn about Redpanda, how our command line interface, RPK works, learn how to create consumers in whatever language you want. It's all free and you can sign up today just by going to university.redpanda.com. And we have other resources available just besides our university. We have our blog posts, which we keep up to date with all the latest and greatest things that are going on. Our documentation, if you need reference material or specific questions answered, or you can always hop into our community Slack. Everybody here who is on the call today is in our community Slack. We love to answer questions and work with you and be available. So yeah, thank you again, everyone, for joining. We really appreciated the time you took to walk through our workshop and go through this event. Thank you all.